Hello everyone, I am Prof.Yadav, worked as assistant professor at SGM College, Karad. In today's lecture, we see one of the basic concepts from mathematics, that is function. Let us see the definition of function. Let A and B be any two non-empty sets, then the subset of A cross B is the function from set A to set B if every member in set A is related to unique member in set B. Here, to define the function, we require any two non-empty sets. Here, we take these sets are set A and set B. Now, we know that any subset of A cross B, that is Cartesian product of set A and B, is the relation from set A to set B. That is, relation from elements in set A to the elements in set B is represented in the form of order pair of elements in set A and set B. Now, if in that relation every member in set A is related to unique member in set B, then that relation is called as function. Here note that sequence is important. That means A to B or B to A. Here we define the function from set A to set B. Now we see the examples on function. Here we take two sets, set A and B, such that set A containing elements A, B and C and set B containing elements 1, 2, 5 and 6. Now in first example, we define set R1 with the set containing order pairs A1, B5 and C5. That means these are the pair of related elements from set A to set B. Now we can observe that this defined R1 is clearly the subset of A cross B, that is Cartesian product of set A and set B. We can also observe that every member in set A is related to unique member in set B. And then by definition of function that defines the R1 is the function from set A into set B. This can also verify by following figure. That is, here is the set A containing elements A, B, C, and here is the set B containing elements 1, 2, 5 and 6. Now by defining the R1, order pair A1 means element A is related to element 1 in set B. Order pair B5 means element B is related to element 5 in set B, and order pair C5 means element C is related to element 5 in set B. Now we can observe that all the elements in set A are related to unique elements in set B. That is, we can observe that element A is related to element 1 in set B, and that element A does not related to any other element in set B, and same also for element B and element C is there. So it is the function from set A to set B. That is, R1 is the function from set A to set B. Now in second example, we define R2 with a set containing order pairs, order pair A1, B2, B5 and finally C6. Now here also we can observe that this defined R2 is clearly the subset of A cross B, that is Cartesian product of set A and set B. But here R2 is not function since element B in set A is related to two elements in set B, that is element 2 and element 5. This can verify by following figure. Here is the set A, here is the set B, and by defining the R2, here order pair A1 means element A is related to element 1, order pair B2 means element B is related to element 2, order pair B5 means element B is related to element 5, and order pair C6 means element C is related to element 6 here. Here we can observe that element B is related to two elements in set B, that is B is related to 2 and B is related to 5 also. That means B is not related to unique element in B, and this neglect the definition of function. That's why this defined R2 is not function from set A to set B. Here we define the function in the form of relation, but we can define function in another way also. That is, in other words, function is defined as if A and B are any two non-empty sets, and for every element x in set A, there exists unique element y in set B such that y is equal to f of x. Then f is called as a function from set A to set B, and it is denoted by function f from set A to set B. In previous definition, we say that every member in set A, we can say element x, is related to unique element in set B, we can say element y. And that pair of related elements is denoted by order pair xy is there. But this is denoted by y is equal to f of x in that definition. And in place of every member in set A is related to unique member in set B, we can say here every element x in A, there exists unique element y in B such that y is equal to f of x. That means x and y are related by the rule f here, and that f is called as function from set A to set B, and it is denoted by function f from set A to set B. Here note that let function f from set A to B be a function such that y is equal to f of x for all x belongs to A. Then the set A is called as domain of the function and set B is called as codomain of the function. That means in function f from A to B, A is called as domain of the function and set B is called as codomain of the function. Also note that in function y is equal to f of x, element y is called as image of element x and element x is called as pre-image of y. Next concept, that is the range, and which is also related to the function. Now let us see the definition of range. Let f from A to B be a function, then range of the function is defined as f of A or R is equal to set containing elements y belongs to set B such that y is equal to f of x for some x belongs to set A. That means elements of set B, that is y, are belong to the our set range if and only if that element y can be expressed as y is equal to f of x for some x belongs to A. That means for element y there exists pre-image x in set A such that y is equal to f of x. Let us see the example of range. Here we take two sets, set A and B, such that set A containing elements 1, 2, 5 and 9, set B containing elements 3, 4, 7, 11 and 30. And we define the function f from set A to B such that f of x is equal to x plus 2. That means image of that function is given by x plus 2 for all x belongs to set A. Then by putting the values of x from set A, we get the images of that function here. That means if we put element 1, that means x is equal to 1, we get 1 plus 2 is equal to 3. That is f of 1 is equal to 3, and same for the all other elements here. Here observe that elements in set B, that is 3, 4, 7 and 11 has pre-images in set A correspondingly 1, 2, 5 and 9. Then by definition of range, these elements are included in the set of range, that is range is equal to 3, 4, 7 and 11. Here note that element 13 in set B has no pre-image in set A. Hence it does not include it in the range set R. And here we can conclude that range set is always subset of codomain set B.